Hello everyone and welcome to STEM School. So in today's video I'll be explaining a topic called similar shapes, which is something that gets asked very often in the exam. So I'll do some exam questions so that you guys know how to tackle these questions properly in the exam. So before I begin, please do remember to like the video and consider subscribing to the channel for more tutorials just like this. Okie doke, let's get started. Basically, this topic is about having two shapes that are the exact same shape, but they are different sizes, alright? You can imagine it like if you zoom into the shape it gets bigger, but if you zoom out of the shape it gets smaller. It's the same shape, but different size, okay? So if you look here, what we have is a diamond. It's pretty small, but here on the right is we have the same shape, but it's bigger. It's a bigger diamond. So what we say is that these shapes are mathematically similar. So a top tip is that whenever you see the words mathematically similar in a question, then you know the question is about the similar shapes topic, okay? So with that being said, there are some stuff you need to remember for similar shapes. Okay, the first thing is that all angles in the new shape are the same as the old shape, okay? So in this old shape here, we have a small diamond. So if we have equal sides, then it's going to be 90 degrees each corner, okay? Now, what this rule is saying that the angles don't change, so that means in this new larger diamond, the corners will also be 90 degrees, okay? The angles don't change. Now, the second thing to take into account is that the lengths of the new shape are in proportion to the old shape in some way. Okay, so say if it's, 5 centimeter each side, this old, smaller diamond. Now, when we go to this bigger diamond, this new shape, say it could be like 15 each side. Okay, so they are in proportion to each other in some way. So basically, if you know the length of the old shape and the length of the new shape, then you can work out how these shapes are in proportion to each other. And that is what we call the scale factor. Okay, this important formula that you need to remember. So basically the new shape is an enlargement of the old shape by applying a scale factor. The scale factor is calculated by the length in the new shape divided by the length in the old shape, okay? So that's typically the first thing you need to calculate in the question. Then you basically use that scale factor to work out different things of the new shape, like the length of the new shape, the area of the new shape, or even the volume of the new shape, okay? So you'll see what I mean when we look at the exam questions later on. But this is a typical question format. You might get a rectangle like this, and say if it's 4 centimeters on this side, and say we're told the area is something like, I don't know, 20 centimeter squared. Okay, so this is the old shape. We know most information about it. Okay, so then we can have an even bigger rectangle, right? And we can say it's 8 centimeters long, and that's the only information about it. So this is the new shape, okay? So say if we wanted to calculate the scale factor of this, right? So we have to clarify what shape is the old shape and what shape is the new shape. We're going from small to larger. So you can imagine the scale factor is going to be greater than 1. So the length of the new shape will be 8, and the length in the old shape will be 4, okay? So what does that give us? So the scale factor is 2. Okay, so that's what you expect if you're going from a smaller shape to a bigger shape, alright? Now, if you're going from a bigger shape to a smaller shape, then the scale factor will be smaller, okay? It depends which one you label as old and which shape you label as new, okay? So now, if we scroll down to the bottom here, these are the last equations that you need to remember. So basically, number 1 is that if you want to find a new length of the new shape, you multiply the old length by the scale factor, okay? Now number 2 is if you want to find the area of the new shape, then you multiply the old area by the scale factor squared. And then the third rule that you need to remember is that if you want to find the volume of the new shape, then you multiply the old volume by the scale factor cubed, okay? These are typical questions that you might get asked, okay? Calculating the new length, calculating the new area, and calculating the new volume, alright? So what I'll do next is I'll show you how to use these formulas in the exam questions, okay? So we'll have a look at that. Alright, so we'll have a go at some exam questions then. So let's see what this first question is saying. So what we have is two pictures that are mathematically similar in shape. So a word of advice, whenever you see a diagram where you're kind of comparing two of the same shape and you also see the wording mathematically similar, that's indicating that you're going to be using the similar shapes topic, okay? So that means the scale factor formula will be in your head immediately and the three other equations will be in your head as well. Alright, so the cost of each picture is proportional to its area. So what that means is the cost is proportional to its area. Okay, so what we'll do is we'll come back to that later on. So the large picture at the top here costs £13.75, and what we have to do is find the cost of the small picture. So basically what we have is we have the large picture. We know most information about the large picture. We're going to use that information to find the other information of the smaller picture. That's basically how it works, okay? So the first step that I recommend you always do is just draw out what you have, okay? So first of all, we have the large picture. What do we know? We know it's 100 centimetres on this side. And we also know the cost. It's £13.75, alright? Now, what do we know about the smaller picture? So the smaller picture, all we know is that it's 60 centimetres on that side, okay? We don't know the cost of it, right? That's what we're trying to find out, the cost. So the first step on how to figure this out is you need to figure out the scale factor. That's always typically what you need to find out first, okay? So if we look at the top here, the scale factor formula is the length in the new shape divided by the length in the old shape, okay? So, but what is the new shape and what is the old shape? You need to be able to identify which is which. So the way you identify the old shape is the shape that has most information about it, okay? So we know a length on the large picture, and we also know the cost of the large picture, whereas in the smaller picture we only know one length, okay? So we know less information about it, okay? So because we know most information about the larger picture, that's going to be the old shape, and then the smaller picture, that's going to be the new shape, okay? So that's how you label old and new, okay? So once you do that, we can use the scale factor formula. So the scale factor formula is the length in the new shape, so write it shorthand, length in new shape divided by the length in the old shape, okay? So we're able to use this formula because we know a length in the large picture, we know the length of the same side of the smaller picture, okay? So you need to make sure it's the same side you're talking about, okay? So let's keep going. What we do is just substitute the numbers in. So the length of the new shape, 60 centimetres, and then the length of the old shape is 100 centimetres. So what that gives you is a scale factor of 0.6, okay? So we've got a couple of marks there already by finding the scale factor, okay? Now the whole purpose of this topic is to be able to use the scale factor to find other information, okay? So what we're asked is to find the cost of the smaller picture. But what I want you to appreciate is that we're also told the cost of each picture is proportional to its area. So why have they told us that? Well, in your head you'll know all of these equations, hopefully, right? So it's talking about area. So what we need to focus on is this equation here. New area is equal to old area multiplied by scale factor squared. What we're going to do is just substitute the word area for cost. That's all it's saying, okay? So let's have a go at writing that. So we have new area. Okay, actually what I'll do is I'll new cost is equal to the old cost multiplied by scale factor squared, okay? So what do we have here? What's the old cost? Well, the old shape is the larger picture, which we know is £13.75, okay? So we can substitute that in, £13.75, and we just calculated the scale factor for being 0.6, and remember to square it. So that gives us the new cost for the smaller picture. New cost is equal to £4.95 when you put that into the calculator, okay? So that's the final answer. So as long as you remember to label the shapes as old and new, you'll be absolutely fine. So just to clarify, the shape that has the most information about it, that's always the old shape, okay? Then the other shape is the new shape, alright? And just remember, you know, typically the first step you have to do is just find the scale factor and then use that scale factor to find other information about it using these three formulas up here. Okay, doc? Alright, so let's have a go at this second exam question then. So what we have here is a diagram of a flag, right? And it's coloured red and blue. So triangle QRT, that's the red section, and then PQTS, that's the blue section, alright? So triangles PRS, and QRT are mathematically similar, okay? So because it says mathematically similar, I know we need to use similar shapes, right? Now, if we look at this diagram, we don't have two separate shapes of triangles, but if I look at this one diagram, I could be able to identify a small triangle and a bigger triangle, okay? So that's typically what happens as well. So the area of the triangle QRT, the smaller triangle, that's 400 square centimeters. And what we have to do is calculate the area of PQTS, the blue section of the flag. So this sort of rectangular shape here, okay? So again, the first step that I recommend you do is just draw out what we have here. So first of all, what we have here is we have a large triangle, okay? So the large triangle, so we have point P, then we have point R, then we have point S. Okay, so what do we know about this large triangle? Well, all we know is that this side is 30 centimeters high, okay? Now this have drawn the smaller triangle, so there we go. Smaller triangle, drawn horribly, but you get the idea. So what we have here is point T, then it goes down to point Q, and then we have point R. Okay, so what do we know about this smaller triangle? Well, we know this side is 24 centimeters high, but we're also told that the area of triangle QRT, the smaller triangle, is 400 centimeters squared. So we can pop that down. Area is equal to 400 centimeter squared. Okay. So after you've done that, what you want to do is be able to label the new shape and the old shape, right? Because we know we're going to have to use the scale factor formula, right? And what we have here is a length of one shape and a length of another shape, alright? So that implies we can use the scale factor formula. So what is the old shape? So the old shape is the shape that gives you most information. So we know a length and we know an area of this small triangle. So what we can do is call this the old triangle, the old shape, and then we can call this the new shape, okay? Now after we've done that, we can just use the scale factor formula. So what is the scale factor formula? So the scale factor formula is the length in the new shape, length the new, divided by the length in the old shape, length old. Okay, so what numbers do we need to substitute in? So the new shape, will be this one up here, the large triangle, so that'll be 30, and then the old shape will be 24, so it'll be 30 divided by 24, so the scale factor will be calculated to be 1.25. Okay, so that's us done a big part of the question already. We found the scale factor. Now what we need to do is use a scale factor to find other information about the other shape, the new shape. So in this case, we're asked to calculate an area of PQTS. Okay, so that's just part of a triangle. Okay, so how I would do it is I would calculate the area of the new shape, right? Then, because that's the larger triangle, I would take away the area of the new shape. I would substitute the area of the old shape by the area of the new shape, and then that will give me area PQTS, okay? So that's the process how we're going to do that. So what, because we're working with area, we're going to use this formula here. New area is equal to old area multiplied by scale factor squared. So let's have a go at that. So new area, which is a large triangle, is equal to old area multiplied by scale factor squared. So what's the old area? Well, it's 400 centimeter squared multiplied by the scale factor, which is 1.25. So that gives us the new area, so the area of the large triangle. So that will be calculated to be 625 centimeters squared. Okay, so we figured out, so we have both areas of the triangles. So now we just need to finish off the question to find this area here. Okay, PQTS. Okay, all we have to do is substitute the areas. Okay, so area of PQTS is equal to area of the large triangle, area nu, take away the area of the smaller triangle, which is area old. Okay, so what we have here, we calculated 625 centimetres squared. So we're taking away 400 centimetres squared of the smaller triangle. So what does that give us? So that gives us an area of 225 centimetres squared. Alright, so as you can see, the first couple of steps were the exact same as the previous question. So we drew the triangles, we labelled it new and old, used the scale factor formula, and then we used that scale factor formula to find the area of the new triangle. But then we had to do this last step here to find this random shape, area PQ2S. Okay, doke. But as you can tell, it's the same process as before. And finally, we have this exam question here. So let's have a look at what we have. So in this diagram, this line TS is parallel to this line QR. Now TS is 5 centimeters and QR is 7 centimeters. And we're also told that SR is 2.6 centimeters, and we're also told that P to S is X centimeters. So what we have to do is find the value of X. Now, this is actually quite a tough question. You know, that's why I put this question at the end, because it's not apparent that we need to use similar shapes. It doesn't mention mathematically similar in the wording at all. The only indicator that we have to use similar shapes is that if I look at this shape, I can split this into two triangles, a smaller triangle and a bigger triangle. But you know, I wouldn't blame you if you look at this diagram and think trigonometry anyway. Okay, so let's do the first step. So what we'll do is we'll draw the shapes that we have. So I'll draw the smaller triangle. Okay, so the smaller triangle is point P to S to T. So what information do we know? Well, I know that this side is 5 centimeters and I know that this side is X centimeters. Now let's draw the bigger triangle, just like that. So we have point P to R and then to Q at the top there. So what information do we know? Well, this side is 7 centimeters and the bottom side is from P to R is X plus 2.6 centimeters. Okay. Now, after we do that, normally we label the shapes as being the old shape and then the new shape. So the old shape is the shape that has most information about it. Okay. But what you'll notice from this diagram is that both shapes have the same amount of information. We know the length of two sides of the triangle. Okay, so before I told you the old shape is the shape that has the most information about it. The only reason I told you that is because it makes the next step of the question easier using these formulas. Okay, it makes it easier rather than having to rearrange some of the stuff. But it actually doesn't matter which shape you label as the old shape and which shape you label as the new shape. Okay, it doesn't matter. As long as you're able to rearrange it correctly, that's perfectly fine. Okay. So I tend to just think about it like, okay, I'm going to enlarge a small shape to a bigger shape, so I'll call this the old shape because it's smaller. Then we're going to have a new shape which is bigger. That's the way I kind of think about it. But you'll get the same answer at the very end if you do it the other way around, okay? So normally the next step is finding the scale factor of that information, right? So the scale factor is equal to the length in the new shape, length new, divided by the length in the old shape. Okay, so to find the scale factor, let's have a look at the diagram. So the length in the new shape, we can use the 7. Okay, so I have the 7. Then the length in the old shape, I can use a 5. Okay, so it'll be 7 divided by 5. So that gives us a scale factor as being 1.4. 1.4. Okay, so this scale factor is greater than 1, implying I'm going from a smaller shape to a bigger shape. Okay, so that's expected. But if you labelled the shapes the other way around as being old and new, then you're going to get a totally different scale factor. But again, it won't matter in the very end because you'll get the exact same answer. So you can have some fun. You can play around with the question and have a go at trying the other way, labelling the shapes the other way around. Okay, so let's continue. So we need to find the value of X. Now, if you look at the diagram, X is just a length, right? We're not talking about volume, we're not talking about area. So that implies we're going to have to use this equation here. New length is equal to old length multiplied by the scale factor. Okay, so let's have a go at writing that. So new length is equal to the old length multiplied by the scale factor. Okay, so what is the new length? So this is the new shape, the bigger triangle. So the new length will be x plus 2.6, so we can substitute that in, x plus 2.6. Then the old length is a smaller triangle, which is simply x. Okay, so it'll be x multiplied by the scale factor, 1.4. Now this is just a linear equation. We can just rearrange this to find x. It's easy enough. Okay, so let's do that. So we have x plus 2.6 is equal to 1.4x. Now I can take the x to the right hand side, so give us 2.6 is equal to 0.4x. Okay, so I have to divide both sides by 2.6, so it will be x is equal to 2.6 divide both sides by 0.4, sorry. Okay, so x will give us 6.5 centimetres as the final answer. Alright folks, so that was a tough question to finish on. So just to remind you, it doesn't matter which shape you label as being old and which shape you label as being new. Just for this particular question, when the same amount of information for each shape is given. But what you normally should do is just label the shape as old if it gives you the most information about it. Okay, so just stick to that step. So hopefully this video has helped you. Please do like and subscribe, and I'll see you in my next video where we'll be finding the angles of complex shapes. So I'll see you guys then.